All right, so again, nothing new as far as any rules. All the rules are out there. But there are a lot of different ways you can see a problem and you'll go, what the heck? And I've had some people from the other class that have come in like this morning and other days and asked really good questions, and those people have like 98 averages. So I'm thinking if they're having questions, you probably have them too, so make sure you get those answered today and tomorrow, all right? I really, like the sheet that I gave you, I'm not gonna lie, there were a lot of really tough, unique kinds of problems. A lot of those you will probably never see again. Some of them, however, you will see. So when you see the homework for tonight, which is more math team log problems, that should be an indication when you start seeing like, oh, he's already put that on there on the other sheet, or I remember that from the other sheet. That's the stuff you really need to be focusing on. So the stuff tonight, a lot of that you're going to see again, and then finally on the review sheet that you're going to have tomorrow night, that will be really more of the level of your test. But don't just study that review sheet. Every year I have a couple people that just, all year long, they kind of just wing it on the homework, they don't check and correct, and they do the review sheet and expect that to cover everything. There will be problems from these log math team questions that will be on your test. And if all you do is look at the review sheet, you very well may not get exposure to those. So if you go to that, to this work, I don't even know what, hold on a second. Okay, so this is what we were on. We covered a lot of these already on Friday. Does anybody have any questions about these that you want to take a look at? I got all day to talk about this, and if you feel completely good and you've checked and corrected everything, start on your homework. Yeah.
I have like 6.
I don't care. Yeah, we got 50 minutes.
Number 10.
Yeah, that's on the I.
So number 10.
And then 13, 15, 16, 20, 22, 24.
That's 6.
No, there's no
6 sounded better.
25 and 29.
Okay, I'll write those there. We'll take a look at those, and my pens are all dead. And we'll add to it. Hold on. All dying at once. New pack of markers like Christmas Day. Nice and sharp. All right. What did you want to add to this?
17. 35. 31.
31.
Oh yeah, 31. And then can you just do number 9?
Number 9. Okay, so what we're going to do is go as fast as we can through these. If we still have time, we'll take a look at other ones. So number 9 right here, this is one we talked about on Friday, and you're doing log base 9 of blog. That's kind of how you need to look at it for now. Log base 9 of something equals negative a half. So when you have a log base 9 of something, how do you get rid of the log? You exponentiate. So I'm going to exponentiate 9. That's going to be the power equals 9. That's going to be my power. So I'm really thinking about it like this. And all that will do for me is get rid of the log, the 9 log 9. That's going to bring me down log base 8 of log base 7 of x equals 9 to the negative 1/2. Now, how do you simplify 9 to the negative 1/2?
3. That's going to be 1/3.
Ends up being 1/3. Now, if it's 9 to the 1/2, it's 3, because the 1/2 part means square root of 9, right? Everybody knows that? So the 9 to the 1/2 is square root of, or the second root of 9 to the first, is what it means. So the square root of 9 is 3, but the negative part means that you have to put it in the denominator. So all of that just means 1/3. All right, now you got another log. So how do you get rid of log base 8? Exponentiate again. And that cancels that. And basically I'm just cheating by doing that to save from rewriting it. And that gives you a log base 7 of x equals 8 to the 1/3. Well, what does 8 to the 1/3 mean?
2.
The cube root of 8 to the first, which is 2. And then finally, I exponentiate again. And that gives me x equals 7 squared, or 49. But this is not a log times a log times a log, because log doesn't mean anything. I can't say, hey, what's the log? That doesn't mean anything, right? It's like with sine trig functions, you do like the sine of an angle, or you do the log of a value. So this is the log of that. So if you just think about it as log base 9 of something equals -1/2, well, how do you get rid of a log? You exponentiate. And that leaves you with that something, which in this case is all of that. And you just do it one step at a time. On this one, that's number 9. On number 10, we've done these before too. If I have to simplify this and they give me this, I have to find a way to rewrite this in terms of that. Now, as in anything, there are some log base 2 values that I know. So what is a base 2 value that I know in addition to these two? Log base 2 of 2 is 1. Now, a lot of these problems are base 10, in which case I know log base 10 of 10 is 1. But in this one, it happened to be base 2, so I'm going to do log base 2 of 2 is 1. And now I've got to see if I can rewrite this right here in terms of a 3, a 7, and a 2. And if I can, then I can break it up and figure out what this is. So let me see. 504, I know 2 goes into that. Hold on a second. Hello, who are you taking? Yes, but hold on one second.
He's keeping us on edge.
Oh, we're putting on the
Alex said we're good.
Oh.
It's kind of fun.
It is kind of fun.
You guys really excited about those.
Yeah, that's right. I was checking to see if maybe they'd switch seats. But they're good. Yeah, that's right. All right, you're welcome. How about?
Yeah.
6th period, you're safe.
Oh, no.
Shoot, I can't. I know, are you not?
Yeah. I'm not legally supposed to say.
Really?
It's like because it's a health thing. You're protected by like bit by herp or something. I don't know. So I'm legally not supposed to shoot. So I'm going to break that down, and hopefully I can get it broken down to 3, 7, and 2. So let's see. 2 goes in the 504, and I do the upside down division. You don't have to. 252. 2 goes in there again. 126. 2 goes in there again. 63. 3 goes, and I like using prime numbers because those are the 3, 7, and the 1 and the 2 are what are prime. 3 goes into that. 21. 3 goes into that. 7. And sure enough, look, 2, 3, and 7. And those are the numbers I need this broken down into. So since that is log base 2 of 2 cubed times 3 squared times 7, we know that the log of a product, right, can be rewritten as logs summed together. Because we know that log of AB is log of A, sorry I'm out of room if you can't see it at home, but plus log of B. So I'm going to write these as sums. So log base 2 of 2 cubed plus log base 2 of 3 squared plus log base 2 of 7. Now here's the critical error half my students make every year. Right here they go and they say, oh, log base 2 of 2 is 1. And they rewrite this as 1 cubed. And they go, oh, log base 2 of 3 is x. So they rewrite this as x squared. Do not do this at home. All right, so this is wrong. But what they're thinking is that this is the same as that. If that was the case, then this would be x squared, wouldn't it? But it's not that. So what do you really need to do on these? Swing those out to the front. Now on this one, you could just look at it and see that it's 3, right? But if you swing these others out to the front, now it's pretty easy to see, oh yeah, that is a 1. So 3 times 1. That is x. So 2 times x. That is y, so plus y. Are you with me? So be careful on those. Don't forget this other value. You know that, right? If it's base 6, you know log base 6 of 6 is 1. So remember that extra value in there, and then break it down and see what happens. All right? So that's 9 and 10. Let's move to 13. So 13 says to subtract subtract these 2 logs and set it equal to that one. Well, to subtract 2 logs, I combine it into 1 log of the same base, which would be base 10, by dividing these 2. So r minus 1 over r plus 2. Do not confuse subtracting logs as dividing. I see people every year, they go, oh, to subtract logs, you divide. That's not true. To subtract logs, you combine it into 1 log and divide those values. But you don't divide 2 logs. Don't do that, okay? And then over here, the problem is my bases don't match, do they?
Yeah.
But that's okay, because what's log base 2 of 2 squared?
2.
2 over 1, which is 2. So I can go ahead and simplify that. And now I'm to here. Now what do you do at this point to get rid of a log base 10?
Exponentiate.
Exponentiate. And again, to get rid of a log, you exponentiate. To get rid of an exponential function, you log. That's the inverse relationship we talked about. That cancels here. Of course, there's no log there to cancel, so I'm just left with 10 squared, which is 100. And you still have this fraction now. But at this point, you're looking at an algebra problem from like chapter 5. How do you solve these?
Multiply both sides by r plus 2.
So I'm going to multiply both sides by an r plus 2. Which again, don't FOIL that, cancel it. That's why you multiply. And you get r minus 1 equals 100r plus 200. And if I subtract an r, I get 99r. If I subtract 100, I get a negative 201. So when all's said and done, I get r equals negative 201 over 99. But look, if I get that value, what happens when I plug that in? It's negative, and I can't log a negative number. Now it would, this is actually bigger than 2. I mean, it's actually like negative 2 point something. So even there it would give me a negative also. But if one of them gives me a negative, I toss it. So no set. And then 14 is a lot like the problem I just did with the 504 in there. I have log base 10 of 2. I have log base 10 of 3. I'm looking for log base 10 of 12. By the way, what other value base 10 do you know?
10.
Log base 10 of 10. So I don't think I need it in this case, but if I did, it's ready to go. All right, so at this point, can I rewrite this in terms of that 2, that 3, and that 10? I bet I can. That's log of 2 squared times 3.
I think 4 is less.
Yeah, we did.
Oh yeah, we didn't want 14. Anyway, sorry.
Wait,
Sorry.
why in 13 did it become like no answer at the end?
Because remember, on a logarithm, the rule is you can only log positive values, and the base of the log has to be positive but not 1. Now the base is 10, so that part's fine. It's positive. But if I plug that number in there, I get a negative something minus something. That becomes a negative number, and I would be logging a negative. I'm not allowed to do that. So if at any point your answer would make it where you're logging a negative or a 0, either one you can't have, right? You can only do positives, then you toss it. And since there are no other answers available, I have to go with null set.
So if it was like R equals 1, it wouldn't be right.
R equals 1, you'd get a 0, couldn't use it. This right here, it has to be bigger than a 1 for both of those to end up being positive. All right, so jump to 15. 15 is, in my opinion, kind of a tricky question. It's probably not something you would see a lot of moving forward, but let's take a look at it. They want you to find this. So that is the same thing as log of x plus log of y. So basically, I need that and I need that to be able to add them together and get this. Now, again, this to me is more of an algebra problem than it's a log problem. And it's, again, not very common. You probably won't see stuff like this again. There's a lot of ways you can work this too. Now, the two things they gave me were these two things. So I'm looking at them and I'm like, well, I need this. Is there any way I can maybe get this from either of these? So I just started playing. I took this first one and went, how can I rewrite a log of a fraction? I can do this, can't I? Because I know that to subtract 2 logs, I would combine it into 1 log by dividing. Right? And then, isn't this the same thing as 2 log x minus 3 log y? Okay, I'm going to put a pin in that and hold it, whatever. Now, what about this thing right here? So this I went to here. Here I'm going to go over to here. Isn't this the same thing as log of x squared plus log of y squared, or y cubed? And this, if you swung the 2 over and the 3 over, would give you this, wouldn't it? So at this point I'm like, well, I've got these two things. What jumps into your head at this point when you see these two things? It's a system of equations. Now, this kind of makes it easy on you a little bit, because if you happen to notice that, you could say, well, why don't I just do this then? Why don't I just call log of x a, and put an a everywhere I see a log x, and call this b, and put a b everywhere I see a log y, and then I'll just solve and figure out what a plus b is, because if I do that, that's basically what I'm looking for now, right? So that's what I did. I think I did that on your... So 2a minus 3b equals 1. 2a plus 3b equals 7. If I change the signs right here, actually I don't even have to. Those cancel. I get 4a equals 8. A is 2. And if I plug a 2 back in there, I get 3b equals, if I plug a 2 in there, that's a 4. And if I subtract the 4, I get that. And b is 1. So a plus b is 2 plus 1 is 3. And that's what that would end up giving me. And that's one way to do it. But to me, this is more about algebra than it is anything. So I don't know. I don't think it's all...
Aren't you multiplying now? Is it saying that?
I didn't find x and y. I rewrote that as the log of x plus the log of y.
Oh, okay.
So I'm actually adding these two values. Now, you can do this another way. Here really just gets you started, and you might like this better. Check this out. I could have just said, you know what, I can change all of these. I could, right here, I can exponentiate with a 10 and cancel out the log base 10 and get x squared over y squared is 10. I can exponentiate here with a 10 and get x squared times y cubed equals 10 to the 7th, which is a huge number, right? And I could just solve that system and solve x and y. It's not great looking, but I can do it, can't I? Yes? Like for instance, what's x squared here? 10 to the 7th over y cubed. I could square root it if I want, but I don't have to. Couldn't I plug this in for x squared right there? If they're both x squared? And I could say, all right, I've got 10 to the 7th over y cubed divided by another y cubed equals 10. How do I divide by a fraction or divide by a number? I multiply by what? The reciprocal of that? So I get 10 to the 7th over y to the 6th equals 10. Couldn't you cross multiply? 10 to the 7th equals 10 times y to the 6th. And divide by 10, and what do you get for y? Y to the 6th equals 10 to the 6th, so y is 10. And if y is 10, what happens when I plug it back in here? Any one of them. Right here, I would get x squared over 10 cubed equals 10. X squared equals 10 to the 4th when you cross multiply. What do you get here? If x squared equals 1, it's got 4 zeros. When I square root it, I get an x with 2 zeros. 100? Or even better, if you have x squared equals 10 to the 4th, couldn't you just square root both sides and get x equals 10 squared, right? 10 over 4 over 2, 10 squared. And then once you have 100 and once you have 10, couldn't you plug them back in here and say, okay, log of 100 times 10 is that? And what do I get when I have log base 10 of 10 cubed? 3. So it just depends on how you want to do it. But this is not a very common kind of question. I hope that your brains expanded a little bit from it, but I wouldn't lose sleep over a lot of that. That's 15. 16 over here. I have a log minus a log equals a log minus a log. What are my rules?
Keep the log and
So keep the log by dividing, and then keep the log and divide again. Now what would you do? Exponentiate with the base 10. And you end up with this. Now what would you do? At this point it's kind of not a log problem anymore, is it? Cross multiply. So that times that gives me 12x squared minus 18x. This times this gives me 9x squared plus 6x. To solve, wouldn't you bring everything over to one side? That would give me 3x squared minus 24x equals 0. What would you do at this point? Factor out of 3x and you get x minus 8. So when you solve, you get x equals 0 from that and x equals 8. Now, when you go back up here and check, does the 0 work? Not because it's 0, but because I'd end up logging a negative, right? So I toss that. Does 8 work? There, yes, there, yes, there, yes, there. So 8 works. But before you say 8's the answer, they didn't ask for x. What did they ask for? Which is just a turd thing to do. Estavia did this, and of course a was 8. And then what you ended up getting is log base 2 of 8, which is 3. Because log base 2 of 2 cubed. But yeah, they did that, and all of our guys, not all of them, but a lot of our guys missed it because they forgot to read the question. All right, that's 16. Let's jump to 17, then to 20. So 17, what are you seeing?
Well, we can move the fractions that are in front of the log.
That's right. Or if you don't like fractions, couldn't I just multiply everything through by a 2? If I multiply everything by a 2, right, which is a lot of times what I do when I have fractions, because that number's out front, it's like a regular kind of algebra problem. So I get log base 8 of x. But you could swing them up. You could. It just makes it start looking a lot uglier. So now it's equal to 4. Now what?
Exponentiate, right?
No, not with 2 logs on one side. But I can add logs by what? Multiplying. I get an x to the 4th. Now I can exponentiate. And I get 8 to the 4th. And what would you do with a 4th root? I mean a 4th?
X.
You 4th root it. and I get x equals what?
8.
Now technically, because it's fourth root, you get plus or minus 8, right? But the negative 8 here, can you log a negative number? So we're gonna go with just that positive 8. And then this one right here, a lot of people make the mistake right here on, nobody asked me about 18, but I wanna talk about it real quickly. Why is this wrong right here, exponentiating with the b and doing this? Because the 1/3's in the way. You cannot do that, but you can do what with that 1/3? Swing it on up here, right? Which makes that be, that would become what here?
Cube root of 125.
Cube root of 125, so at this time that's a 5. Well, that shouldn't be a big deal, all right? 1-to-1 property or exponentiate, either way it cancels and you get 5. Number 19, nobody asked about, how about 20?
Yes.
All right, number 20 is very similar to the 504 problem and the other problem we had. You're looking for this, but you know these two values. Now again, I'm going to give a bonus this year that if you have those two values memorized, you'll get some bonus points and you can maybe solve a couple other problems, get a few more bonus points. But you're not going to need to have those memorized on your test. So if on your test I say, hey, log base 2 of x is x, you use x. Don't go, oh, well, I have that memorized, it's 0.301. No, it's x in my problem. Are you with me? Until the bonus. But here, remember, what else do I know? Log of what? Log base 10 of 10 is 1. So I'm going to factor that up, and when I do, here's what happens. Because I'm trying to figure out what this is. I get a 2 cubed, and then I get a 3 times a 5 squared. Now the problem with this is I'm good with the 2. I have a value for this, of log 2. And I'm good with the 3. And it'd be great if I had a 10, but I had these two 5s. Okay, so 5s are 10 halves, right? But instead of writing in there 10 halves squared and having a fraction and a fraction, could I do this mathematically? Could I just multiply the top and the bottom by a couple more 2s and just turn those into 10s? I'll show you both ways, but yes, you could. So watch this. Because I'm doing it on the top and the bottom, what I really have is 2 to the 5th on the top, a 3 on the bottom, and now I have 10, 10. Now, I'm going to show you this way, and then I'm going to show you the other way, and you're welcome to do the other way, but there's one little caveat people run into. If you do it this way, if this makes sense to you, you'll avoid this careless error I'll show you about. So at this point, how can I break that up? Log of 2 to the 5th, and then that's because it's in the numerator, it's the positive value, but because these are in the denominator, minus the log of 3 minus the log of 10 squared. Are y'all seeing that? Of course, I need to swing the 5 out, swing that 2 out front, and then now I can substitute in there, and in there, and in there. So I end up with 5 times the log of 2, which is a 0.301, minus the log of 3, which is a 0.477, minus 2 times the log of 10, which is a 1. And all I got to do now is just be careful with the algebra, or the whatever. So this ends up being a 1.505 minus a 0.477 minus a 2, and to save ourselves the pain of having to deal with this, and again, you won't have to deal with this on your test, because I'll have like log of 2 is x, log of 3 of y, and you would just go 5x minus y minus 2, and you'd be done. So you won't have to get caught up in this. But just to show you the math of it, I want to do this because I want to show you the other way. 5 times 0.301, 5 times 0.301, minus 0.477, minus 2. You should have ended up with this. Now let me show you the other way that most people do. They do it this way and they run into careless errors. But at first it's great, but it can definitely get you in trouble. Check this out. Most people do this. They go, oh, 8, 2 cubed, this, 3 times 5 squared, and they go straight to log of 2 cubed, they swing the 3, minus log of 3, minus log of 5 squared, and they swing the 2. And if you did that, that's awesome. There's nothing wrong with this. And they come in here and they go, all right, log of 5. They probably get this part down. And they definitely get this part down. And then they get to here and they go, oh yeah, 5 is the same thing as a what? And they put a 10 halves in here. And all of this is great so far. And then here's what happens. Right there, they go, oh, this, and they do a lot of this in their head, and they write, oh yeah, that's log 10 minus log 2, right? And they do that, they go 1 minus 0.301. If you do this separately, you're okay. The problem is, so many people do this, and this especially happens if there's not a 2 out front, and they forget to distribute that number in, or that negative in. But if you keep this in parentheses, like this, as you're doing the math, and you keep it in parentheses the whole time, like this, are you following me? Then you're okay. But the problem is, people, they write this down, and they usually just drop the negative. And then it looks like they have 2 negatives here, because they forget to distribute that negative in, or they forget to add this first. But if you do it this way, you're great. I just would rather address the 2 5s initially and go, hey, 25 on the bottom, I can make that 25 on the bottom a 100 by just multiplying by a couple of extra 2s. And then I just break that up and I'm good. But that's my opinion. But you're fine right here as long as you remember that 10 halves, do that, but put it in parentheses and remember to distribute that negative in or add this stuff together. You follow me? Okay, so that is number 20. And if anybody does any of these differently, speak up. I'd love to hear what you have to say. Here's 22. Okay, number 22, a lot of people do this. They swing the 3 out front and make it an 18. Problem is the 3 is not with just the 8. The log rule says if you have a value right there with just this, then yes, you can swing it out front. That is true. It does not say this. See, this ends up being that times a log. This ends up being log of m that many times being multiplied together. That's totally different. So if this is the case, I can't swing that number out in the front, but I still have to get rid of it. So how do you get rid of a cube? You cube root it. Now, I think we may have talked about this in my other class, but maybe we didn't get to this one in here. Without a calculator, how do I figure that out?
TTK.
Yeah.
What's TTK?
It's basically like a Powers quiz, but for like a bunch of other things.
It's like 100 questions.
Oh, she called it TTK?
Things to know.
Oh. Well, how about this? ICS, impressive common sense.
Oh,
Dude.
Okay?
hold on.
Now, you're right about, you might not have even thought about it, but based on what you're saying, you're thinking this is probably a whole number. Probably is. But I just don't know what it is. I don't have my cube roots up to through a couple thousand. But I do know this. I know a couple of powers of 3. Like I know 10 cubed is what? So I know that the number's bigger than 10. And I know that 20 cubed is, careful, I'm cubing, so it's 8 with 3 zeros. And that's way too big. So here's what I know. The number is definitely in between these two, right? And when I cube it, it has to end with an 8. So what numbers, when I cube it, end with an 8?
6.
Wow.
It's gonna be 2s.
It's not 6.
6 is actually when you square them or cube them, they always end in a 6.
It's 12.
But 12 would end in an 8. And it would make sense, right? Because 12 cubed, I think it's going to end in an 8. And it's also a lot closer to that than it is to this. So let me just see, just to double check my math. I know 12 squared, you probably know this is 144. So when I multiply by another 12, there is my 1728. So I checked it out, okay, that is 1728. What do you do with a negative on a cube root? Just bring it out. So that's just a negative 12. And when I divide by a 6, I get a negative 2, and then what would you do to get rid of the log? Exponentiate, and I get 8 equals x to the negative 2. Now at this point, don't freak out. What would you do? What is x to the negative 2? Yes, but what is x to the negative 2 the same as? So if that makes it better for you to change it to this, great. What would you do to solve that? If you, yeah, it's one way. So if you multiply by x squared on both sides, those would cancel, and I get 1 equals 8x squared. And then what? Divide by an 8, and you get x squared equals 1 over 8, and then what? And when you square root it, you get x equals what? 1 over 2 root 2, and then you rationalize, and you get root 2 over 4. Now technically you get plus or minus, but can a base be negative? So I keep the positive. Now that's one way. I'll tell you that's not what I would do though, because there's a lot more math. Watch what I would do right here. If I ever have a fraction equal to a fraction, I can flip both sides. And I get 1/8 equals x squared, and I'm ready to go. Square both sides from there. That's if you have one fraction equal to one fraction. You can flip both sides. Anyway, that's 22. Let's look at 24. Okay, again, 24, we've seen a lot of them like this. It just looks uglier. It says, if that's true, find this in terms of m. So this is an uglier version of this, but I'm looking for log base b of 4. Now, isn't log base b of 4 the same thing as 2 log base b of 2? So really what I want is that. So let's see if I can rewrite this as a log base b of 2. Okay, so that right here, I'm coming down with this. That's log base b of 1 over 2 to the 7th. Okay, that's a great start.
You could just do like 2 to the negative 7.
Even better start. Now again, I need log base b of 2.
And then you swing the 7.
Swing the negative 7, and I have that. And again, I need log base b of 2.
Divide by negative 7.
Divide by negative 7. And you have log base b of 2 is m over negative 7. So if that is m over negative 7, couldn't I use that in place of that? And I get 2m over negative 7, or negative 2m over 7. And that would be rewriting this in terms of m. That is probably not something you'll ever see again. It's just a little random ciphering question, probably the state you had back in the 90s. Doesn't feel very familiar to me. 24, let's look at 25. It says, and if the solution of that is 1, is written in the simplest form. So you solve and you write it in that form, then what is m plus n? Now that's just their way of it was probably a written test question, and they probably didn't want to write your answer where you could plug it back in there and guess and check. You know, just grab the answers and plug them in there and see what was true. So they said, hey, your answer, if it's written like this, so if your answer, for instance, was like root 5 over 2, they're saying take the 5 and the 2 and add them together, and what is it? So let's just solve this. How do you solve something like that on 25? Great, so I'm going to keep the base, and again, I don't know why they put the 10 there. I'll do it because they did it, but it's understood. So you combine it into one log by multiplying, and you get 36x squared. Then what would you do? And when you exponentiate, then what would you do? Divide by 36, and when you simplify that, you get 5/18. I'll tell you what, why don't we just leave it, because we're about to square root it and it'll look better. So when I square root it, what do I get?
Root 10 over 6.
Root 10 over 6. Technically, I get plus or minus, but the negative doesn't work. So is that in simplest form? So since it is, what is your m and your n? So the 10 and the 6, add them together and you get 16. I don't know if I'll do a lot of that on your test. I might once or whatever, but it's not important to me. That would be fine. But this is just what Vestavia would do. They always ask you that last little bit to see if you're in a rush and you're not paying attention, then you're not missing. 26. Do y'all know how to do 26?
I put in numbers.
Okay, let me ask you a question. What's the main thing that throws you on 26?
There's no numbers.
Bases.
There's no numbers, but there's all kinds of what?
Bases.
Different bases. Is there a way that you can rewrite logs so that they're all the same base? So that's one thing you can do. That goes back to my whole mentality of, right? If there's one thing you can do, try it. Everybody with me?
Yeah.
Stay locked in there. So what that means is that log of A, this is my change your base rule, over log of B is C, and log of B over log of X is also C, which means these two would be equal to each other. But I am looking for log of X over log of A, because that's what I'm asking you to find, right? Now, the problem with you guys is a problem everybody faces, is you're used to wanting to find an answer. Like, you're probably looking at this and going, to get this, I need to find A and I need to find X. But you don't. You need to find log of X and log of A and make a fraction out of it. Can you find log of X or log of A from these two equations? It's not too hard either, right? Here, to find log of A, all you got to do is what? Multiply both sides by A. Log of B, here you go. There's your log of A. You get C log B. Does everybody see that step I just made? I'm basically multiplying by log B on this side, log B on that side, and they cancel, and I get that. Right? And then here, can everybody see what I would do here to find log of X? Or even, how about this? Flip both sides. So log of X over log of B is 1 over C. And then you could just multiply by log of B on both sides. Are y'all seeing that? Yes, no? And you're home free now. I'm going to take the log of X, and I'm going to plug that on the top. Log of B over C in the numerator for that. And then I'm going to take log of A and plug that on the bottom. And I need to simplify this. So how would you simplify that?
I put C log B. I would do 1 times, or log B over C times 1.
Great, so she's saying to divide by a number, I take the top number and I multiply by the reciprocal of the bottom, and the reciprocal of the bottom would be 1 over C log B, and the log B's would cancel, and I'm left with 1 over C squared. And that is probably not something you're going to see a lot of. But it was an old, again, these are all, I think most of these came from Vestavia, I believe, not all of them. And if ever I see a new, different kind of problem, I usually throw it in here, replace a different one. But you'll see, well, I don't know if you'll see or not. I just got an email today about this person doing the state tournament. They're going to try to do a version where you just come in here and we test you, and then we mail off the tests. But it won't be until April. Well, we don't cheat. We don't need to cheat, dude. We can get all these number ones down here for
Right.
cheating,
My bad.
right? Okay, so that's 26, but yeah, I imagine there might be some crooked schools.
Yeah.
But my guess is if they're that crappy, their person in charge probably doesn't know how to help them cheat.
Probably.
So good luck.
What, we can beat them even if they cheat.
That's right. That's 26. How about 29, 31, and 35? We'll try to squeeze those in there. 29, this is a very common one. The thing that you're supposed to see here to get you started is x plus 2, and what is that? Which is x plus 2 quantity squared. And this is where it normally goes south. So log of 10 all of it squared equals log of 10, just the x plus 2 squared. Now, people usually get stuck right here. They go, oh, that's the same thing. It cancels. It's an identity. No, it's not the same thing. Is there any one thing you can do here in the purple?
Oh, was that two?
Which two?
Oh,
The one on the left or the one on the right or both?
that was right.
The only the right. Because this 2 is with the whole log. The only time you can swing it is if it's just with the part you're logging. So that yes, I can swing the 2 out in front, and that would give me this. I want to see if anybody can get it from here, because if you can get it to here, you've done a lot. This is where most people go, what the heck now? But anytime you get to what the heck now, if there's something you could do to make it seem better, what do?
Just try it.
We make look, don't you see the same thing here as you do there?
Oh, you make a
Oh, yes,
substitution.
you make a substitution. So what if I said, let A be log base 10 of x plus 2? Now there's still a lot of things that can go wrong. Now I have a squared equals 2a. Well, I can solve that. How have we been solving these? How do we solve
Take
any
out an
problem?
A. Take out an
Well, we set it equal to 0.
Divide by A.
By the way, don't divide an A out. If you ever divide an A as an answer, you've just thrown the answer away. Let me give you an example. Right here, a squared equals 2a. If you divide both sides by an a, you get this, don't you?
Yeah.
Right? Because the a cancels, But doesn't 0 also work?
Oh, yeah.
Where'd it go? You just divided it away.
It would find out.
But if I factor it, watch, if I set it equal to 0 and factor it out instead of dividing it out, then it's sitting there reminding me, oh yeah, don't forget to solve for that part, which gives you 0 and 2. Now, once I get to here, what do?
Okay.
I go back and I plug the log base 10 of x plus 2 back in for a, and back in for a on the other one. And then how would you solve these?
Exponentiate.
Exponentiate here. X plus 2 equals 1. X equals -1. And believe it or not, -1 works. Check. And then how would you solve here? Exponentiate, and x plus 2 is 100. And x equals 98. And both of these work because they give you positive values.
Can you show us to like the first part of 31 really fast? Or like the 16?
Yeah, 31 is really one that I wanted to get to. If you want to wait 1 minute, if not, I will try to finish it up and you can go back and watch the back of this video. This is a tricky problem, but I can almost promise you it'll be on your test. Follow with me. If that's true, right there, and it's base 10, what would it mean if I exponentiated with a base of 10? What that means is I've just told you another way to rewrite the number 2. You can type that in your calculator. It's not going to give you exactly 2 because this is a rounded value for that logarithm. Are you following me? Now, if I want 2 to the 124th, couldn't I, if they're both equal to 2, couldn't I raise that to the 124th power? And now here's the beautiful part of this. You'd have to do that math out to the side, but watch. If you know that new power, which is 37.324, don't you know how many places, how many digits numbers have when you're dealing in base 10? Now look, 10 to the 37th would have how many digits? 37 zeros, plus a 1, 38 digits. And 10 to the 38th would have 38 zeros with a digit. That'd be 39 digits, right? Well, this is not yet that big, is it? It's a little bit smaller than that, so it's still a 38-digit number.
Wait,
It makes sense.
why is it?
It makes
Like,
sense.
it's because it hasn't reached 38 yet?
No, it's past 38. But remember, there's lots of 38-digit numbers, right? So it's bigger than the smallest 38-digit number, but it hasn't quite yet ticked over to be a 39-digit one.
Because like can you round it?
Because it's somewhere in the middle.
Okay.
I'll talk more about that tomorrow. because I rushed through it, but
Which one do you need to look for tomorrow?